We are going to talk about complex numbers now in chapter 5, which I know a ton of you are just like, woohoo, super excited about because we had a lot of fun with those back in college algebra. And again, just a kind of reminders, this first section here, and that's what I'm going to go over in these notes, is just kind of the general stuff, review of what those complex numbers are, how do we add them, multiply, divide, do exponents, things like that. That's what we're going to do here on this one. So let's pull this up. Again, just a little review, complex numbers, it's a different dimension of numbers. So we kind of go vertically, and we'll do a little more of that in the next section. So I'll explain that a little bit more as well. But again, a complex number, or sometimes called imaginary numbers, they aren't really, because it works really well for understanding how electricity works. Complex numbers get used for that. So in here, the square root of -1, that is what we put as I, right? And so that's what we're going to go through today. How do we add them, multiply, powers, dividing, or using those conjugates as well. We'll do a few examples of that. So our first example here, any negative square roots, we're now going to put those as I, right? That's what a negative square root is. So in this case, like the square root of 50, the square root of 50 we can break down. That's 5 times 5 times 2, right, or 25 times 2. So the square root of 50 simplifies down to be 5 square root 2, and then since it was negative, we just put an I after that, right? With the square root of -81, we know that the square root of 81 is 9, so then we would say that that is 9i. We wouldn't say that it's -9i unless it also had a negative on the exterior of that as well. So that's kind of just a little reminder. Whenever we got the negative under, we simplify the square root like we would regularly, and then the negative square root becomes I, right? Adding complex numbers, just like we would add anything, we add their like terms together. So in this case here, we'd add the 8 minus -1, so that would be itself 9, and then we'd have 3 minus 4, which would be -1i, and you wouldn't have to put the 1 there if you don't want to. I'm going to put it there for emphasis, but you could also just put 9 minus I as well. So adding or subtracting, not too bad on there. Multiplying them is just like we would do with anything with variables in that. We just distribute everything through there. So when we multiply these two things, we might take 8 times -1, that's -8, and then we might take 8 times 4 here, which is 32i, and we just kind of go down. We have -3i from these two together, and then 3i times 4i being plus 12i squared. And normally that's kind of where we might stop a little bit. Well, not quite stop, because we could put these two together quite simply and say that that's 29i in that case. But we might stop there when we add variables, but we can go one step farther with complex numbers, because we do know that I squared is the same as -1, right? Because I itself is the square root of -1. So I squared is -1, meaning we can put these two together. We have -12 and -8, and that would make -20 in that case. So we can always go a little bit farther with that stuff, right? So there's your kind of steps where we went through, but that I squared becomes -1. So those different exponents we can simplify as well. That's something we had went over before. We kind of talked about it kind of like it's going around a circle, right? We start at 1, I to the first power pops up here to I to the second power becomes -1, like we just talked about. I cubed would be -1 times I, or we would put down here -I, right? And then I to the fourth power would be all the way back up here, because that would be very similar to doing -1 times -1. We get 1. And then it's just going to keep going around and around and around. So every fourth power, right, every fourth power, you're going to circle back to 1. So you should, like any exponent, you'll never have an exponent bigger than 1 on i's, because we'll always be able to simplify that in some way. So a couple examples on there. All right, you can either use the circle method or you can go around. Here I can say, I to the 18th power. I could take 18 divided by 4, and I would know, well, that's 4 with a remainder of 2, right? That's what that is. So I'm going to put that in there. 18, divided by 4 is 4 with a remainder of 2. So that would mean really this thing is the same as using, we just look at the remainder, because all these groups of 4 just are spinning around the circle. They don't actually do anything. So all we do is take that remainder and say, oh, that's got to be the same as this remainder here when we divide by 4, which again, I squared we know is -1. And so that we can simplify all the way down to -1, right? So that's kind of a way you can do that. Some other ways you can do the same thing here. Divide it by 4. This one has a remainder of 1, so it should be I, right? That's what we can do there. Another way that you can look at this is if we take our 201. Maybe I take my 201 divided by 4, and I don't want to worry about the remainder so much. Maybe I grab my calculator there and I just type that in because I wasn't quite sure. 201 divided by 4, and say, oh yeah, that's 50.25, right? I might know that. Well, what this would mean, right, this extra 0.25 in this case, right, would just mean that that's a quarter turn around the circle, right? A quarter of a way around the circle. Let's take that and we'll put that in. Oops, I want to fill that. I mean, that's what that would mean, is that this is just a quarter turn around the circle. That's what that part means on there, right? So, I mean, we could also take that's what that 0.25 is going to do, is gives us a quarter turn, which means we're going to end back up at I. So I to the 201 is in fact just I, right? Because it's a remainder of 1, or 25% of the way around the circle, right? So that's what that one becomes, right? That's there. And I to the -5, you do the same thing. It's just like negative numbers, we're just, or negative angles, we're just reversing direction. So here, -4 would end us back at 1. -5 would come through this way, and we'd end up at -I in that case. So in that one, we'd know that that's -I in there, right? So that's how we can simplify stuff with exponents. It's not too bad. Again, if you got other questions on those, you can send those my way. So you can either do it by remainder, by counting around the circle, or by saying, oh yeah, what percent of the circle did we get through as well? So you can do that, right? Then that's multiplying powers. Last item we're going to go over here today is how do we divide things, right? And the thing we have to keep in mind, a reminder, is we have to use conjugates when we're dividing complex numbers. And actually there's a second way we can do that, which we go over in the next lesson as well. But for right now, with these ones, you can use conjugates also, right? And this is the key piece to keep in mind. Conjugates, again, being that we'd have something added and then something subtracted. But when we multiply something times its conjugate, we just do the first part squared, technically minus the second part squared. But because I squared is -1, we get to just add them together when we use complex numbers. That's the super cool and exciting part, and it's super awesome, right? So to go over one example of what that might look like, here are some complex numbers being divided, right? To divide those things all the way out. And I'm just going to grab these here so I don't have to retype the whole thing on there. Okay, we'll edit that equation. So here on this one, right, we would need to say, well, we have this top spot, the stuff on the bottom, that's what we want to use as our conjugate. The conjugate of that denominator is 5 minus 2i, and we have to make sure to use that, oh boy, on both numerator and denominator. Let's see if we can get that to, or I can get that to format correctly on here. There we go. 5 minus 2i, we put part of it on the numerator, and we have to put part of it on the denominator as well, right, where we apply this conjugate in there. And if you want to keep track of that with colors, things like that, you certainly can. And then from there, well, we just work that out like we normally would. The denominator, not too bad, because again, you can distribute it all out and combine stuff, or we can know that's 5 times 5, which is 25, plus 2 times 2, which is 4. So the denominator is going to be 29. And you can distribute all that stuff out, combine like terms, change the I squared to a negative. You can double check all of that stuff. But we can use that quick formula that we looked at before and say that's what that bottom is going to be. And then this numerator stuff, well, we just have to there's no quick way to do that. We just have to work that part out. 4 times 5 is there. 7i times negative 2i is negative 14i squared. And then we just kind of have to work through 7 times 5, suppose it's 35i, and 4 times the negative 2 is negative 8i. There's no quick or easy way to do that. And we just work through. This is going to become positive 14. So we can put all that together and say that's 34. We can put these two together. 35 minus 8, I suppose, being 27. And there we have now put that all, we've worked that all the way out. Now, there is a little bit, not too much more to add here, but just to clarify, some instructions and stuff like that will sometimes say, hey, put things in the form of A plus BI, right? A plus BI. And this is not quite an A plus BI because it's being divided by something. So very simply, and you don't have to do this in your homework, but it's just here for clarification. If I want to put this in form of A plus BI, well, what we would do is we would separate that denominator there. And now it's A plus BI, right? So it's the exact same thing. There's not a whole lot going on in there. It's just separating that, so there's just the stuff that has no I value in it, and then the stuff that does have I value. So if you see that in the instructions, that's what that means. It just means separate those two things out there. And so again, you guys have your assignment. If you guys have questions on that stuff this week, shoot me an email like you guys have been doing and let me know. Otherwise, good luck.